Today we're going to look at multiplying fractions using models, and we're going to look at actually various types of models to use. So I'm going to start out by reading number 9. It says, Jody has a 5-pound bag of potatoes. She uses 4/5 of that bag to make potato salad. How many pounds of potatoes does Jody use for the potato salad? So when I always do word problems, I always want to start out by using my cubes. Again, C is standing for circle, and we always circle the number and what it represents. So I'm going to go ahead and circle 5-pound bag of potatoes. The other number that I see is 4/5. And when it's talking about 4/5, it's talking about uses 4/5 of the bag. So I'm going to circle that as well. Next is going to be the U. I need to underline the question so I know what it's asking me. The question says, how many pounds of potatoes does Jody use for the potato salad? So now I've done my C and my U, and I'm at the word B. So for B, I'm supposed to box my operation word, and in this case, my operation word is actually the word of. Of tells me to multiply. So I am going to now move on to my E. I want to evaluate an expression to solve this. So in order to solve this, again, I need to look back at my information. I need to know that I'm figuring out how many pounds of the bag Jody is using, and I know that she has 5 pounds and 4/5 of it is being used. So I'm actually going to be multiplying 5 times 4/5. So now let's go ahead and take a moment and look at, well, what does that mean using a model? So I'm going to take this beautiful piece of paper here. So you know what? Let's go ahead and bring that book back. What I'm going to do in order to make this more effective for you is I'm actually going to freeze frame that word problem there, and we'll just leave it on the side of the screen so that we can refer back to it whenever we need to know what's going on. So let's zoom it out a little bit so I can slide it over. Okay. So we're just going to leave that freeze frame there. And now I'm going to go to my piece of paper, and I'm going to look at different ways that I can represent it using different kinds of models. So I'm going to turn my paper going this way so I have more space. And in the center, I'm going to write 5 times 4/5. So again, I'm actually going to come up with different ways that I can describe this expression 5 times 4/5. Now, the first way that students tend to be more comfortable with when modeling is to actually draw rectangular models. So since my whole number is 5, I'm going to draw 5 whole rectangles. So 1, 2, 3, 4, and 5. Now I have 5 whole rectangle models. And so now what I'm going to do is I'm actually going to take those 5 rectangular models and I'm going to divide them into fifths, because that fraction bar represents division, so I'm dividing by 5. So let's see, I need to draw 4 bars to represent 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so you can see now that by drawing those 4 bars, I actually have divided into fifths. 1, 2, 3, 4, 5. So now they're divided into fifths, but I actually need to shade 4/5 of it. So I'm going to go 4, 4. Now I always tell the students to do quick shades because it really isn't important that it's perfect. It's just important that I have the map down. So I've done my quick shades, and now I have represented 4 times 4/5 using a model. The next step really is to count how many I have. Well, there are 4 shaded in each, so I can just count my multiples. 4, 8, 12, 16, 20. So I actually have 20 shaded, and they're divided into fifths. So I have 20 fifths. Now one thing that I tell them is that this also represents division once again, so this is the same thing as saying 20 divided by 5, and 20 divided by 5 is 4. So when I'm looking back at that problem, how much does she use? Well, 4/5 of 5 is actually 4 pounds. So she uses 4 pounds. But that's just one model that I can use to represent this equation. And again, I'm going to look at multiple ways. So another way that I can use is I can use circular models. So I'm going to draw again 5 whole circles. Now I tell them that it is important that they're about the same size because when we're comparing, we want to compare the same whole. The example that I use in class is that if I'm eating a medium pizza, that's not the same thing as if Mr. Stutz is eating a large pizza. You can't compare how many slices we ate if the size is different. So I've drawn 5 whole models, and again, I'm going to divide them each into fifths. So we don't worry about being perfect. We just kind of try to get it there so that we can count the parts. So I'm trying to divide them all into fifths as equally as I sort of can. Yeah, it's good enough. Looks like a little kid throwing their hands up in the air. All right, so I have now sort of divided them all into fifths. And again, I'm going to shade 4 of the 5 parts. So 1, 2, 3, 4. 1, 2, 3, 4. Now I tell them it doesn't matter where you shade it, doesn't matter where the empty spot is, as long as you have 4 of your 5 shaded. So I did it in different areas just to demonstrate what that should look like. And again, if I count these up, I'm going to notice that there are 20 shaded out of 5, so I'm able to represent it again in this kind of a way. So we have now done the rectangular model and we've done the circle model. However, there's another model that's a little bit more complicated but is necessary to know, and that is with a number line. So I'm going to make a number line. Let me slide my paper over so you can see it. And I'm actually dividing my number line off into fifths because that's my unit fraction. And I'm going to start my number line off at 0. And I have 1/5, 2/5, 3/5, 4/5. 5/5 is 1 whole, so there's 1. 1/5, 2/5, 3/5, 4/5, 5/5. There's 2 whole. 1/5, 2/5, 3/5, 4/5, 5/5. There's 3 whole. 1/5, 2/5, 3/5, 4/5, 5/5. There's another whole. So in this case, it's actually telling me each time I jump to jump 4 fifths. So 1, 2, 3, 4. Well, that represents 1 pound. But I have 5, so I need to jump 4 times again. 1, 2, 3, 4. Oh, 4 times again. Sorry. So I jumped my 4 times again, and now that's 2 of my pounds. Jump my 4 again. 1/5, 2/5, 3/5, 4/5. There's 3. Again, I'm going to jump 4. 1/5, 2/5, 3/5, 4/5, and there's 4. And my final 5th jump, because I'm doing 4 times 4/5, 1/5, 2/5, 3/5, 4/5, and that's my 5th, and it actually lands directly on the 4, which is what we learned it equaled here. This is a little bit more complicated, but it is necessary to know, so we try to practice it as much as possible. So I'm going to go ahead and circle that. That's another way that I can represent 5 times 4/5. Again, I took my number line and I divided it into fifths, and each time I jumped 4 fifths. I had to jump 5 times because I was multiplying it by 5. Now there's another way that we can represent it without a model, but again, it is necessary to know. Since I know that 5 whole, when it's divided into 4/5, that I'm really just multiplying my whole number by my numerator, I can also represent it as 5 times 4 over 5. So that's another way to represent, again, my whole number times my numerator over my denominator. So I'm just going to draw that. That's another way to describe that expression. And then again, there's another way, so many ways, yay. I can also do it using repeat addition. So what I'm going to do is I'm going to take this fraction 4/5, and I'm going to actually add it 5 times. So it have 4/5 plus 4/5 plus 4/5 plus 4/5. I've got 4 times, and one more time is 5 times. Now again, if I wanted to add that to check my work to make sure did it actually work, I would just count 4, 8, 12, 16, 20, which is what I had here. And when I'm adding fractions, my denominator is going to stay the same, so it'd still get 20/5, which is equal to 4 pounds. So now when I go back to my original question, it was asking me how many pounds of potatoes does Jody use for the potato salad? Well, since she uses 4/5 of 5, 4/5 of 5 is equal to 4 pounds. Now again, I showed you many ways that you can represent that. We do need to know all of these ways by the end for our unit assessment. However, we have plenty of time before we actually have to be at that part. So again, the ways that I can represent it, I can represent it with a rectangular model. I can represent it with a circle model, a number line, multiplying my whole number by my numerator, my denominator stays the same, or with repeat addition by adding 4/5 5 times. So they're just some of the ways, some of the many strategies that we can use to help us when multiplying a whole number by a fraction. Good luck, guys!